Okay, well, very good. I'm Tim Clark. I'm the president of Stockton Astronomical Society, and I want to welcome you to the October 12th general meeting. Good to see everybody in person as well as online. I usually ask for guests to introduce themselves or at least say hello. Do we have any guests in the room that are not members or first-time guests? Anybody there? Okay. And then on Zoom, we know Lonnie. Thanks, Lonnie, for joining, and Edmund and Lilibeth. Glad to meet you, and thank you for joining. Okay. Anybody else? Well, then let's go ahead and get started. We'll jump right in, and I'll do the introduction for our speaker tonight. We'll have a brief group of announcements, and then our closing with. But let me go ahead and jump right in to introduce Jeff Baldwin. This is kind of a special honor for me because Jeff has been my teacher and my mentor for years now, ever since I joined the SAS. And so it's really a privilege to introduce Jeff because he is at the upper level of amateur astronomy, I would say on the verge of basically a professional astronomer, and the activities and the experience that he has. So hang on to your chairs because this is an introduction that's meant to kind of highlight Jeff's career as an amateur astronomer, as well as inform you all of what a great resource, what a great amount of knowledge and experience we have in the club with Jeff is one of our key members. So he's been in the club since about 1990 when he first moved to the area, and he's been observing since he was 9 years old. So easily over 50 years of observing. He is a graduate of Eastern Washington University in mathematics, with a master's from National University, a teaching degree there. And Jeff served as the Airborne Astronomy Ambassador for the NASA SOFIA program. SOFIA is the Stratospheric Observatory for Infrared Astronomy. Quite the privilege to serve in that capacity. I think Jeff and Laura did a lot of work to prepare and then go on that flight. If you ever want a real great story and a lesson about infrared astronomy, talk to Jeff about his SOFIA mission. Jeff's been teaching for over 37 years, he told me. So quite the accomplishment there in his teaching career. And he estimates that he's taught astronomy to over 1,500 students. Quite an impressive number right there. Over his lifetime, he's owned and operated about 20 different telescopes of his own. He's observed many different solar eclipses, 1979 and 91, 92, although he tells me he was clouded out those years, and finally got clear skies in 2012 and the total eclipse in 2017. He's observed from Hawaii, Nevada, the Snake River Canyon, and Malibu in Southern California, Iceland, the Philippines. So this guy's been all over observing the skies. So he's not just observing, but he's actually done a lot of work to earn several different astronomy certificates from the Astronomical League. They include a Messier certificate, a Herschel certificate, a Herschel II certificate, the binocular Messier certificate. That's got to be a tough one to get, identifying Messier objects with binoculars. We'll have to talk about that sometime, Jeff. The Deep Sky Binocular Certificate, an Outreach Award, the Caldwell Observing Award, and the John Hewitt Memorial Award. So congratulations, Jeff, on all those AL certificates that you've earned over the years. He tells me he's probably made over 400 mirrors in his shop and in his career as an amateur telescope maker. And I think you're actually graduating into professional now that you're doing it full time, Jeff. So, his knowledge of the night sky is unparalleled. And I've got to admit that many times I go to star parties with the sole intent of just mooching off Jeff's observing. And so my technique is I'll set up my telescope just kind of nearby him and wait around until he says, "Hey, come check this out." And then I go over there and I look through his 24-inch scope, Chester, and get the most glorious views of whatever deep sky object Jeff has in the viewfinder in the eyepiece. So, Jeff, I got to admit that my experiences with you at star parties are memorable, educational, and I always look forward to them. Although I have to warn you all, if you go to a star party with Jeff, you've got to be prepared for his sense of humor that breaks out when the sun goes down. And he has this fondness for Helen Keller jokes that I'm not sure everybody would really appreciate. So, but without any more introduction, then I just want to introduce our guest speaker for tonight, Jeff Baldwin. Let's give him a round of applause.
I don't know where you want me, Rick.
Right there is fine.
Right here. Tim, thank you. That was a glorious introduction. These people are going to be really disappointed after hearing all that and having to put up with it they're about to put up with. I promised that everybody that came here tonight was going to get a prize. And so I'm going to hand out Eclipse goggles to everybody here. So if you guys can give me just 1 minute, I'm going to hand them out right now. You people at home? You should probably hand them out at the end, so we have to stay.
That's right.
We don't fail. Yeah.
Hey, Doug, grab a pair for me, will you?
I got my own stash, Jeff.
Double check them, make sure you didn't poke any holes in these.
Okay, so we have a lot of new faces, and every month I write down who's here, and then I hand it to Tim so we have a record of who's here. So Tim, I'm going to introduce everybody individually so you can write it down because I can't write it down for you. So I'm going to watch Tim. When I see him get ready, I'm going to do that. You ready?
Yep, ready to go.
So I'm Jeff Baldwin, and over here is
Casey Foley.
Casey Foley.
Kathleen Chapman.
Gail Rieger.
Forrest. Michael Chapman.
Are we going too fast, Tim?
I got it.
Okay.
The other Chapman.
Aaron Collin.
Neanderthal.
Dennis.
Bill Light.
All right, out at home, I see Lara. How you doing? I see Lonnie.
Doing good.
I see Edmund and Lilybeth. I see Christy. I see Tim and Jerry. And hi, Bill. And my sister Jackie. I don't see her, but her name's there. And Glenda got a hold of me, said she can connect. So if there's anybody else out there I'm not seeing, I apologize for not getting to you. All righty. So I guess I'll go ahead and start this thrilling show. This is my opening slide, and so I guess we can go to the next slide. Okay, so the reason we're having this talk tonight is because the day after tomorrow, we have an eclipse. And here in Stockton, it will be a partial eclipse, about 78 or 79%. I didn't hear what they said.
I didn't make it out.
Was somebody asking a question?
It was Bill Thomas.
Bill's muted. Did anybody have a question out there in Zoom land?
Okay, I thought I heard somebody ask something. Okay, so we have about a 78 or 79%, here in Stockton and San Francisco and Sacramento. Our side in Nevada, it's only 89%. And you might ask, well, why isn't it 100%? And the reason is the moon is smaller than the sun from our point of view. And therefore, we have what's called an annular eclipse, where you can see the sun all the way around the moon. So if you're going to be looking at this, write those times down, because when the slide changes, you won't be able to see that. So 3, 2, 1. Okay, next slide. Okay, so the question is, what can go between the Earth and the sun viewed from the Earth? So we have Mercury and Venus. Those are called transits. I'm not going to see any more of those, because the next Venus one is 100 years away. And the next Mercury one, I'll be like 90. And so I'm done with those guys. The other thing is the moon. And so this eclipse and the one in April are going to be it for me, because this is the last annular eclipse in America for 20 years. And I have no idea when the next total eclipse is going to be. Every now and then an asteroid goes between the Earth and the sun. However, yes, sir.
You do when the next film.
What's that?
You do know when the next film is coming.
April? Yeah, I'm saying after that one, I won't be seeing anymore. Yeah, April's a biggie. Okay, so then we have asteroids that can go between us and the sun. But in researching that, the asteroid class that orbits between Earth and sun are so tiny that from our point of view, they're only 0.05 arc seconds in diameter, and we cannot see them. And then, of course, human-made equipment like the International Space Station and stuff like that. And so, and one more thing I'm going to go with. Doug just interrupted me to ask something, to clear something up. Anytime somebody wants to ask something, please interrupt me. I don't care if you interrupt me in the middle of a sentence. Okay, next slide. Okay, so this is a photograph of the transit of Mercury that happened back on Veterans Day of, I forgot what year that was now. Was that 2016? I can't remember.
Yeah.
So if you look at that, on the left side of the sun, there's a sunspot, and in the just below center is Mercury. And so that's the last transit of Mercury I'll see. The youngsters out there, we're going to have another one in maybe 30 years. There's going to be one sooner than that, but it's on the other side of the world. So maybe you'll be over there. So Mercury is 3,000 miles across. The sun's 864,000 miles across. So it's tiny compared to the sun. But in this picture, it looks larger than that because it's only 2/3 as far away from us as the sun. So if it was as far away as the sun, it'd be even smaller. So Mercury looks larger against the sun than it actually is. Okay, next slide. And we could see the transit of Venus that happened in 2012. So the picture on the left is my photograph taken from right here in Lathrop. And again, Venus in this picture is only 1/3 as far away from the sun, maybe 1/4 as far away as the sun. So if we try to compare the size of Venus and the sun, Venus is actually much smaller, but because it's so close, it looks pretty big here. And this is the only opportunity you ever get to see Venus round. The only other way you can see Venus is a partial phase. You never see it when it's full, and everything else is a gibbous, half, or crescent. So the only time you ever get to see Venus round is when it's in front of the sun. Of course, none of us alive here will get to see that again. Okay, on the picture on the right, during this eclipse, I arranged with a friend of mine in New Zealand to take a photograph simultaneously of Venus during the transit. And so we timed it so that the Earth was rotated around. So I was on one side and New Zealand was on the other. So we had a good 8,000 mile spread. And we both took a picture, and one of my students put the two pictures together, sized them up, and rotated them around so they matched perfectly with the sunspots and the limb. And we could see the parallax of Venus between us and the sun. So hundreds of years ago, they knew the ratios of the distances of the planets, but they didn't actually know how many miles it was to the sun and stuff. And so it would take a transit like this to do that trigonometry to compute how far the sun and how far Venus and how large they all are. And so we did that experiment in my classroom. And we were off, but we were within an order of magnitude. So I was perfectly happy with our results. And so it's kind of a neat little double exposure there. Okay, next slide. So the other thing that can go between us and the sun is, of course, the moon. And this is a photograph I took in Oregon during the 2017 eclipse. And notice that the photosphere of the sun is completely covered by the moon. And the reason is the moon appeared to be just a hair bigger than the sun. On this particular moment, this is during the beginning of the eclipse. And so on the lower left, you can see the chromosphere of the sun shining around the moon. A few minutes later, the chromosphere was on the other side of the sun at the end of the eclipse. But as far as the photosphere, the bright thing, it's completely covered here. So all you can see of the sun are part of the chromosphere, the red, a couple prominences, which are also red, and then the pure white corona. Now, this is a color photograph, and that is the color of the corona. It is as white gets. There is just no color in the corona. It is just pure white. And my photograph's a little weird. I got a really high contrast photograph, so it's kind of a dramatic looking thing, but it's not what I was after. But nonetheless, there it is. Now, the moon is as dark as it can get because the only thing illuminating this side of the moon is a full Earth. And so it looks black in this photograph because it's properly exposed for the solar features. I do have another photograph where I stacked images, and one of those is a longer image, and you can actually see details on the moon, and they're blue because the only thing illuminating this side of the moon during an eclipse is a blue Earth shining onto it. And so when you look at it, it's just as black as it gets, but you do a time exposure, you can actually see blue features on the moon. Okie dokie, next slide. Day after tomorrow, we are going to have a different kind of an eclipse. It is an annular eclipse, and that's where the moon appears to be smaller than the sun. So even if you're perfectly lined up on the right path, you see the sun all the way around the moon like this. Now, this is a filtered photograph. The other one, the total eclipse, was not filtered. That was just straight through. But this actually shows photosphere around the moon, and the photosphere is bright. I did something stupid at the last annular eclipse back in 20, whatever that was. And just for a brief moment, I looked at annularity just to see just how bad it is. And whoa, it's just like looking at the sun. It was stupid. I'm not going to do that again. So even though that ring looks like, yeah, we can look right at that. No, do not look at this eclipse. There is no moment in this eclipse that is safe to look at without a filter. So this is the kind of eclipse we're having day after tomorrow. Okay, next slide. So there are 4 types of solar eclipses. There are lunar eclipses. I'm not talking about them today. These are just the solar eclipses. So a partial solar eclipse is when part of the sun is covered and they're not, you can't see the sun all the way around it. And so that's what Stockton and San Francisco and Sacramento will see Saturday. For about an hour and a half or 2 hours, there will be partial phases. Then there is a total eclipse. That's the kind we're going to have in April if you're in Texas or Mexico or Indiana. And that's where the moon completely covers the sun, other than the corona. And then there's the annular eclipse where the moon looks smaller than the sun. You can see the sun all the way around it. And then there is the hybrid eclipse. And I got a little demonstration of what a hybrid eclipse is in a future slide, but that's where for part of the planet, they see an annular eclipse. And then for another part of the planet, they see a total eclipse. And then later on, in another part of the planet, they see an annular eclipse again. So it goes from annular to solar to annular. Okay, next slide. So this is an extremely exaggerated illustration of the Earth and Moon orbiting the sun. And we orbit in an ellipse with the sun at one of the foci of that ellipse. And so if we were to the left of the sun, we would be really close to the sun and the sun would look big. But if we were right of the sun, way out there on the right side, we'd be far from the sun and the sun would look small. So from our point of view, the sun looks largest in January and smallest in July, because we are at what's called perihelion on January 4th. and at aphelion around July 5th. A lot of people think, well, gee, it's cold in the winter. Why isn't that when we're closer to the sun? The answer is nope. Okay, so I drew the Earth and the moon orbiting. I should have done that a little differently, but you get the point. And let's go to the next slide. Similarly, the moon orbits the Earth in an ellipse with the Earth at one of the foci. And so if the moon were off to the left of the Earth, the moon would look large to us. That would be at perigee. And if the moon were way off on the right at apogee, it would look small. And so the moon changes its size from large to small on a 29 half-day basis. Excuse me, 27 on a third-day basis. Okay, next slide. So this, I'll get through this quickly. This is no big deal. I just want to make a point with it. The average distance from the center of the Earth to the center of the moon is 239,228 miles. Now, the Earth has got a radius of 4,000 miles. The Earth and the moon has a radius of 1,000 miles. So if we were standing on the side of the Earth, pointing towards the moon, the surface of the moon would look 5,000 miles less than that number. But we're not going to worry about that right now. Now, because of this apogee-perigee thing, the moon can be as close as 223,700 and as far as 251,700. So that's quite a large differences in distances and therefore a fairly large difference in apparent size. Now, the sun is 93 million miles away, but can be as close as 91,400,000 and as far as 94,500,000. So if you look at the ratio of distances between the sun and the moon, it is a 1 to 389 ratio. I'm going to round it off to 1 to 400. If you look at the difference in size of the moon and the moon 2160 miles and the sun 864,000 miles, they are a 1 to 400 ratio. So how cool is it that the ratio of their distances is very nearly the ratio of their sizes? Therefore, they look the same to us for size. So if I were to look at Eric from 20 feet and somebody half the size of Eric from 40 feet, they would look like they were the same size from my point of view. Does that make sense? Okay. Okay, so if we talk about angles, the average size of the moon is a half a degree, and the average size of the sun is a half a degree. So they're the same with variations of large and small. So the smallest moon we get is 0.492 degrees, and the largest moon we get is 0.553 degrees. And the smallest sun is 0.524 degrees, and the largest sun is 0.542 degrees. Now, those are not true, because when I did that, I did it from the center to the center rather than from the surface to the surface, which would be more accurate. But to get the point, sometimes the sun looks bigger and sometimes the moon looks bigger, is the point of this whole table here. So let's get rid of that table.
Excuse me, Jeff.
Yeah.
Excuse me, Jeff, before you move on, let's go back to that 1 to 400 ratio of both size and distance.
There you go.
That seems very suspicious, like a coincidence of nature. Is there any explanation to how this occurs, or how these two ratios got to be the same? And is there any indication it occurs anywhere else in the solar system or the universe?
We're very unique, and it's only now. 1 million years ago, the moon was much larger because it was closer. Every time the moon orbits the sun gives a little fishing hook yank on it, and it's a little bit further. So 1 million years ago, the moon was much closer. 2 million years ago, it was very much closer. 1 million years from now, it will be further. So because of this tug by the sun, the moon is creeping further and further and further away. So right now, we have that ratio. But 1 million years ago, we did not have this ratio, and 1 million years from now, we will not have that ratio. As far as other planets in the solar system, there are no other magic ratios. Either the moon is much smaller than the sun, or the moon is much larger than the sun. If you look at Phobos and Deimos on Mars, they're much smaller than the sun. If you look at Ganymede, Io, Europa, and Callisto, they are much larger than the sun. Then at Saturn, some are larger and some are smaller. So this is just the only planet that does this. We're not a planet and moon, by the way. We're a double planet. But the moon doesn't have that. When the moon looks at the Earth, it's 4 times bigger than the sun. So it really is just this particular moment in time that they're the same size. Did I answer your question on that?
You could say we're very unique and maybe even peculiar.
I think it's awesome because the gift of eclipses is a wonderful gift. We would have never have discovered the corona if it weren't for this magic event. Can you imagine never even knowing the corona was there forever? I mean, that's crazy. Okay, did I answer everything okay, Tim?
Thank you, Jeff. There was a question in the room.
Oh, what was that?
I think he asked if there was a question in the
There
room,
was
but
a
no.
question in the room.
Okay, go ahead and click again here. Okay, so I have 2 circles here, and we'll let one be the sun and one be the moon. Now, the moon is closer to the sun, so then the sun can never go between us and the moon. It's bigger than that distance, but the moon can only go between us and the sun. So if the moon is the guy on the left and it's in front of the guy on the right, we would have an annular eclipse. If the moon's the guy on the right and the sun's the guy on the left, then when it gets in front, we'll have a total eclipse. So it just depends on who looks bigger than whom when we have an eclipse. Okay, next slide. So this is an illustration of a total solar eclipse. That incomplete circle on the right is the sun. The circle on the left is the Earth, and the moon's the one in the middle. And notice that as it casts a shadow on the Earth, Eric, could you put the mouse and point to this stuff right there? Yeah. Right in that area right there, we're on the surface. We're not in the interior. We're on the surface of the Earth. And so if you're on the surface of the Earth right there, the sun would be completely blocked by the moon, and we would have a total solar eclipse. But if we were over here, we would have a partial eclipse. If we were over here, we would have no eclipse. Sound good? So let's go to the next slide. And this is an annular eclipse. So if we were right here, notice that the cone of the shadow of the moon does not make it to the surface. So if we were standing on the surface, we'd be able to see that the sun is just a little bit bigger than the moon, and we would have an annular eclipse. And of course, if we were right here, we would have a partial eclipse. And if we were right here, we'd have no eclipse. Okay, the next slide is the hybrid eclipse. So on a hybrid eclipse, their sizes are just almost exactly the same. But if we were right here, we would have an annular eclipse. If we were right here, we'd have a perfect eclipse. If we were right here, we'd have a total eclipse. If we were right here, we'd have a perfect eclipse. If we were right here, we'd have an annular eclipse. Now, perfect eclipse would be really cool. They only last a split second, but for that split second, the photosphere is gone, and you'll be able to see chromosphere all the way around the moon. I think it would be a bummer because your eclipse doesn't last very long, but how cool would it be to see the entire chromosphere around the moon? I think that'd be cool. So that's a hybrid eclipse, and they happen more frequently than you might think. Okay, next. So the question is, why don't we have an eclipse every month? Because you got to figure that during new moon, the moon is between us and the sun. Then during full moon, it's on the other side. Then during new moon, it's between us. And during full moon, it's the other side. Why don't we have an eclipse every month? The bottom line is that the plane that the moon orbits around the Earth is tilted 5 degrees from the plane that the Earth orbits around the sun. So when the nodes are lined up, we get eclipses like here. We get solar eclipses and lunar eclipses. But over here, notice that the tilt allows the full moon to be above the plane, and so there's no lunar eclipse. And over here, it's below the plane, and there's no solar eclipse. So we don't get an eclipse every month. So the next question is, why don't we get an eclipse every October and every April? Well, because that plane that is tilted 5 degrees, takes 18 years and 11 days and then 8 hours to precess around. So this year, the eclipses are October and April. Next year, the eclipses will be September and March. A year and a half later, they will be in August and February. And they go around and around and around. And so you can go back to 2017 when we had an eclipse in August. That Soros cycle is rotated around. So now the eclipses are in April and October instead of August and February. So we don't get eclipses every month. And the months that we get eclipses rotates around in an 18-year cycle called the Saros cycle.
Question.
Yep.
Are there places on the planet that never have an eclipse? So
The question is, are there places on the planet where there are never any eclipses?
Yeah.
There are not. Every place, given a right amount of time, will have an eclipse. So I looked to see when the next time Stockton has an eclipse, and it's a couple hundred years away, but it will. And so the eclipses happen over the North Pole and South Pole, and they're kind of like a glancing eclipse. They happen in the tropics. They happen everywhere. Australia seems to be just the luck of the draw. If you look at the past 30 years and the next 30 years, they seem to get, Australia and Indonesia for some reason seem to get the lucky break. And of course, California gets the unlucky break. But that's just the way it is. And that's not like there are good spots and bad spots. If we were to look between the years 2600 and 2800, there would be other lucky places. So right now, the lucky places are Indonesia and Australia. Okay, next.
Why is it called the Saros cycle? Is Saros somebody's name?
Yeah. And that's been known for centuries, if not millennia. So Saros, somebody might fact check me on this. Saros was a long time ago. And I don't remember the story, so I'm not going to tell you. You want me to make up a story? Okay, way back in the day. No. Okay, next slide. All right, so Saturday's eclipse is going like this. So that's where I'm going to be. I'll let Eric catch up here. Right there you go. North of Winnemucca. And at that point, it will be an 89% eclipse. Now, notice as we come down here, it goes to a 90 and 91% eclipse. And the reason is the distance from the moon to the surface of Earth is smaller down there because the moon's that way instead of that way. And so the size of the moon is a little bit bigger with respect to the sun as we head towards the Gulf of Mexico. And as we head down beyond that, it once again gets smaller again. So this is an early morning eclipse for us. And so it'll only be 89% outside of Winnemucca. As you can see from this diagram, Stockton is about 78 or 79%. San Francisco is about 75%. Sacramento is about 77%. Find your place. If you look at Texas, Christy here is joining us from Texas. Hi, Christy. She's in East Texas, so she's going to be over here and probably maybe 80%, 81%, somewhere over there. Okay, next slide.
Actually, a little bit farther east.
Are you almost in Arkansas?
Almost Louisiana.
Can you go back there, Eric? We're going to go back to that slide. And so you're right at 80% then.
Yeah, just about where that pink line is.
Okay. So you're going to have
Right
an 80% eclipse. Now, the cool thing is we're going to be on one side and she'll be on the other side. So she'll have a crescent on one side of the sun and we'll have a crescent on the other side of the sun. That'll be kind of neat. Okay, next slide.
She'll get it at a later time now, right?
Okay.
It's going north to south, right? North.
I'm not sure I heard what you said, but
It's moving from north to south, though, right?
correct.
So she'll get it at a later time.
So if you could match me with your pointer here, right here, we're probably talking about 9 o'clock in the morning. And for Texas, hey, Christy, have you figured out what time your maximum eclipse is? Your local time?
And muted.
It's easier to hear. If
Sorry.
you mute.
I have not done that yet, but I plan to do it probably when we get off here.
Slacker.
Sorry.
Jeez. Okay, so my guess is that the moon's shadow tends to go about 1,000 miles an hour. So 8 o'clock here, be 9 o'clock here, but it'll be central time zone, so we'll call it 10 o'clock there. So my guess is you're gonna have maximum eclipse in the vicinity of 10 or 10:30, but I really don't know. I'm just guessing. Okay, next slide.
I'm sorry, on that map, right here.
Yeah.
There's like another pink line going.
That's the 90% barrier. See, that's a 70% line, 8% line. So that's a 90% line. And right there, the moon is close enough to the surface of the earth that it just breaks the 90% line there. Okay, next slide. Okay, so this is hilarious. This is just, I can't believe this happened. I arranged with a guy in Texas to see the eclipse from his ranch. And so I've been in contact with him, and I thought, you know what? I'm going to send him his goggles now because I'm sure that he's going to be able to see this annular eclipse too. So I get on the map and I look at his ranch, and guess where his ranch is? Right at the intersection of these two eclipses. So this place I'm going, I didn't know when I arranged it. He gets both an annular eclipse and a total solar eclipse in a 6-month period of time. So how lucky can you get? So anyway, these are the two big eclipses this season here. If you remember the eclipse from 2017, it started up there in Oregon, went through Idaho and Wyoming, and ended up down there in South Carolina. And so the path was totally different back then. I mean, that's just, the paths are different. So if you're interested in going to both of these eclipses, then there's your map right there. Notice that the shadow of the moon up there in Nevada is very eccentrically elliptical oblong. That's because it's low in the sky and the shadow is being cast at an angle. And they get rounder as you get further down here because the moon is more overhead. And the shadow, it tends to be around. When it gets way off here, okay, this is sunrise over here. Notice your shadow is in the incomplete ellipse. That's because it's skipping off the earth there. Okie dokie. Next slide.
Actually, wait a minute. I wonder where the space station is going to be during the eclipse, and because they're going to be able to see the actual shadow.
Yeah. So going from there to there takes a number of hours,
Right.
and they're around every an hour and a half.
You're going to see even if it's cloudy, they're going to see.
Oh, yeah.
The shadow.
It'll be a safe bet that they'll be able to see something from somewhere. And yeah, whether it's a shadow.
They might even be running through, get their own eclipse at some point also.
Yeah, I don't know about that because, when they orbit across here, that might be when the shadow's there.
That's true,
So
too.
they may get it, they may not. I have not researched that.
I'm sure somebody at NASA has.
Yeah. That would be very cool. Whether it's shining, whether it's projecting down onto clear ground or cloudy ground, they're going to see a shadow either way. They may not see a shadow because it's not a total eclipse. There may be some darkening. Whether they can see that or not, I don't know.
That's true, too.
Because you know what I've noticed during annual eclipses? It's weird. You'd think, it's going to get dark because 90% of the sun's gone. It should only be 10% as bright out. But your eye compensates the whole time. And it's just so subtle you can't tell. It's weird. You can kind of tell, but you got to have maybe an 80% eclipse before your brain can start registering, hey, it's dark out.
Yeah, the last eclipse here in Stockton, when I was here in Stockton, you could tell.
Yeah, when I was at totality, I was probably 10 minutes away from totality before I'm going, it's starting to look different now. I was surprised by how much my eyes compensate. Okay, I was clouded out at a total eclipse in Washington in 79. I was clouded out in the eclipse in Hawaii in 91. And on both of those, as it got darker and darker and darker, my eye compensated. But that last couple of minutes, first of all, when it's cloudy and you've spent thousands of dollars and years planning for eclipse, you are pissed off big. Your emotions are absolutely haywire. If you could just clear your mind and appreciate it, eclipses during cloudiness is still really cool. I mean, you're just too pissed off to tell, but it's still cool. It's like God is taking the light switch and going, zzz. Right? It's weird looking. You can literally see the light fading away in front of you. It's very cool. If you could just not be mad at the moment, it's really cool.
Did you notice the weather changing too when it was cloudy like it did in Oregon? I mean,
Yes, in total solar eclipses, it gets cooler, it gets quieter, the birds quit chirping, and then they come back. The weirdest part for me was after in Oregon, when I had a clear eclipse, when the eclipse was over and the lightness was coming back, everything was the wrong color. It was so weird. Everything was the wrong color. And then that went away in just a moment, but it was very cool.
It's the birds and the insects.
Yeah.
So yes, that. And about 11 degrees cooler. It's great.
I know of a project where people were scuba diving at Cabo San Lucas to watch fish behavior during that 7-minute eclipse back in 91. And I don't know the answer to that. You want me to make something up?
No.
The fish all went to sleep and then they came back. Like, I really don't know.
I'm jumping out. Everybody.
I'd hate to be a fisherman. Hey, they're not biting, man. What's wrong here? Okay, next slide. Okay, so this is eclipses from 2021 to 2040. So this is a 20-year period of time coming up. Now, the blue ones are total eclipses. The red ones are annular. The magenta ones are the perfect eclipses, the hybrid. So you might look at how wide those polar eclipses, look how big they are in Antarctica and up in the polar region, but they're not. This is a projection. This is a cylindrical projection. And so everything's all goofy near the poles. And that's why Greenland looks 15 times the size of Mexico, even though Mexico's actually bigger, right? So there's that problem. But at the same time, they are a glancing eclipse. They're skipping over the tangent of the planet. So they actually are wider. So if you look at this red one right here, I'll let Eric point with me with this thing so the people at home can see. That one right there is April. That's going to be the one, everybody. But no, that's the one in October. I'm a doofus. That's his one coming up in October right here. The blue one is the April one, and that's going to be the one. And notice that for April's eclipse, Mexico will be the most intense part of the eclipse. My nephew, Eric, is going to go right down there to see the eclipse. I'm going to be right about there. Now, if you look at the day after tomorrow's eclipse, it's overhead down here in Central America. So right there, the shadow will be, well, it won't be a shadow, but the greatest annulus will be very circular, where up here is very oval. All righty, so if you look at this eclipse right here, you can point this one right here. This one is total and then hybrid, and it turns into annular. If you look at this one right here, it is annular.
I can't see past you.
Annular, then total, then annular. So that's a hybrid. And they'd be really cool, except you travel all that far, spend all that money for like 1 second of eclipse. So I don't know. You'd have to be really into the chromosphere to do that. So if you look at the United States in this picture, there ain't anymore. This is it. I mean, for a guy my age and all crippled up, this is it. There's a Canadian one coming up. There's an Icelandic one that I'm kind of interested in. I'll have to talk to the boss about that one. But honestly, when you look at some of these, I don't want to go to the Middle East to see an eclipse. There's 3. Look at 4 in Australia. How lucky. Australia and Indonesia. How lucky can you get down there? So that might be an interesting target to try for some future eclipse. But as far as here in America, the next 2 coming up in the next 6 months, that's it. And I know I won't live long enough to see any more there. Some of these are kind of a bummer. They are entirely over water. And on top of that, that's not just water. That's about as far as you can go to get to water. I mean, that's way out there. Out here in the Pacific, there's a lot out there, but God, the Pacific is big. Notice that this eclipse right here is blue. And then when it pops in on the other side over here, it's red. Whereas that one right there is all blue. So that's kind of a fatty for what might be a hybrid eclipse. So maybe in Alaska, maybe in Canada, maybe Iceland, maybe not. I think Australia's the ticket. Take your pick. Okay, next slide. Okay, I want to emphasize this first point here. At no point can this eclipse be observed without filtration. It's not like a solar total eclipse where for 4 minutes you can take the filters off. This eclipse, there is no point that is safe to look at without filter. I want everybody to understand that. These goggles here, they can't see it on TV, but these goggles here, they are safe to look at the eclipse. They are not safe to look at the eclipse with a pair of binoculars shining that hot light onto the plastic that will burn them. So they are meant just to be used alone without any optics on it. Okay, so there are some projection methods. And so, Eric, is it possible for a minute to pop off of the PowerPoint and onto a camera? Is that a possibility?
I think at home they can still see you over there.
Y'all at home see me okay?
It's really
We can, but it's very small.
Okay, well, if they can see me, I want to show you Tim's solar projection telescope. And is that a good place to put this? I don't know where your camera's at.
Yeah.
Okay, so maybe, is that the kind that you can move around?
so I have stopped the share, so but they should be able to see you.
Is that something we can do for a minute?
What do you want to do?
I want them at home to see this.
Lift it up a little bit.
Do you need to see more than what you have there?
Yeah, just lift it.
Well, I was just going to show you the whole contraption, but I can hold it up.
Lay it on the table, Jeff. We can almost see the
Actually, lay it
table.
on, that's it, lay it on the table.
New from KTEL, the new Astroscope. So, where am I? There we go. Okay. So Tim made this. Ed Reibel and I made a couple for the Sky Mountain Outdoor Education Center, and they work pretty good. So what it is on that end is a 60 millimeter f/15 refractor telescope objective, the kind you throw in the garbage. Right here is a Barlow lens, and it projects a Barlow projection onto this paper here. And believe it or not, it's actually quite awesome. You can see the solar disk, you can see sunspots. So whatever photospheric items you can see in a scope, you can see on this. The cool part of this is it's totally safe. You can't burn your eye. There's nowhere to stick your face in here where you're going to burn an eye. So it's really good for kids to look at this. The other feature he has on here is he's got this. I'm not going to roll it up, but he's
Just tip it up. Just grab it and pull it up, Jeff. You
Set
can't.
up, set straight on the table. There you go. Set it.
Oh,
There you go.
okay, good.
Perfect.
There we go. Ooh, look at that. So this is a prism. Looks like it's acrylic. It's not glass, but it still works. And he can project a spectrum of the sun so people can see that the white light of the sun can be projected into the colorful spectrum. Now, an acrylic prism like this and a 1/2 degree diameter sun, you can't see the Fraunhofer lines on this. What I'd like to do to show Fraunhofer lines, those are the black lines in the spectrum, is I take a hotel desk bell, ding, 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 that's chrome, and I put it on the ground, and it has a little tiny image of the sun on it. You take a diffraction grating and you look at it, and you get solar spectra that's really thin and sharp, and you can see the little black Fraunhofer lines in there. So,
What would a glass prism do versus acrylic?
with the 1/2 inch sun, there's no advantage.
Okay.
So to get Fraunhofer lines, you got to have a slit to straight into spectrum. With a half diameter sun, either way, you're just gonna get a continuous spectrum with no indication of Fraunhofer lines. But it's still pretty, and it shows people that different wavelengths of the sun are.
Shows basic physics.
Yeah. So anyway, this is really neat, and Tim would be happy to show you how to make one of these. And if you harvest the parts from throwaway scopes, it costs as much as some pine and some screws, and that's it. And Tim did a really good job on this. I'm really impressed with this. And you just
The
get.
prism might be the most expensive bit on there.
What's that?
The prism might be the most
Yeah,
expensive bit on there.
eBay that price for like $80, you know. So another good way to observe an eclipse or is that the camera there?
Right here.
Another really good way is to take a piece of paper and you take a pencil and you stick a hole in the piece of paper. Then you hold it in front of you and look at the shadow of the piece of paper. It will project a solar image. So it's always round, like today it would have been round, but during the eclipse, it'll be crescent shaped because it's going to take on the shape of whatever the illuminating source is. So theoretically, for me in Nevada, I will get a little circle. Here in Stockton, you get a crescent. And today you would have just gotten a disc. So that may be the single safest way to observe the eclipse is a hole in a piece of paper, look at the shadow. I have my students take a secondary mirror from a telescope and put it on a tripod and then steer it over to a wall about 200 feet away, made a sun about that big. And of course, it looked like a crescent because of partial phases. So that's another good way to observe the eclipse. Use eclipse goggles is a safe way. But without filtration, projection's the ticket. Direct viewing, yeah, don't do it. Doug.
Missed one. Your piece of paper with the pinhole, a colander,
What?
a colander, like you string your spaghetti with.
Oh, yeah.
And you catch the sunlight and you get dozens of little eclipses.
Lonnie, where's Lonnie? There. Turn on your microphone and tell them about what you did with your projection.
That was fun. When we were up in Idaho for the total eclipse, I made a pattern of Idaho with holes. And when it hit the ground, we had all those little crescent moons of Idaho with a shape. It was really neat.
I think my wife, if I took her colander and made a map of California out of it.
There you go.
Well, the reason he told me that in that story was I was at his house last night. We made a mask for a 24-inch Hartman mask for a telescope. I was taking it to my car and a car shined its lights at me and all these holes were on my car. I thought, hey, that'd be really great for the eclipse. I told him about it, and then he told me about his map of Idaho. Okay, so Tim, thank you for this little guy here. Okay, the other way to take a look at it is to watch it on TV or the internet. But you know, we're astronomers. We like to see things ourselves. Okay, next.
Let me reshare here.
Hey Jeff, I got a question.
Yeah.
300mm zoom lens with appropriate filters with the f-stop all the way down and the shutter speed all the way up.
I'm going to show you a picture of the sun I took today here in a minute. And the way I did it was I took a Canon EOS T2i digital single lens reflex camera. I put my 250mm lens on it, set it to f16, ISO 400, a 200th of a second with that filter right there. And you'll see what it looks like here in a minute. It was a little bit underexposed, so you might try f8. So you might just bracket and take a lot of pictures and see which one works best. But yeah, it'll work great.
I was just curious because I do a lot of darkening where I can actually bracket.
There you go.
Change the f-stop there.
If you bracket, you're gonna nail it. And the sun, I mean, when you're magnitude -26, there's always an exposure you can get. It's not like the NGC 4. Well, I wonder if a second will work. No, you need 10 minutes, you know. Okay, are we back onto this one here?
Well, yeah.
Gracias. Okay, so this is the end of the show, but I just thought I'd show you some eclipses. On the top left is Jupiter having an eclipse with I don't know which two moons they are, so I'll just say Ganymede and Io, even though I don't know which they are. But you can see that both the shadows are on there. If you look at one below that, that is Phobos being eclipsed by the sun, taken from one of the landers on Mars. So notice that the only eclipse you can get from Mars would be partial eclipses or annular eclipses. If you look at the bottom right, the moons of Saturn orbit the ring plane. And so the only time they get eclipses is when the ring plane is very close to pointing at the sun. So this photograph was taken during one of those times. And the top right photograph is a shot I took today with my Canon. So I got my telephoto lens all ready to go with a filter, and I had to make sure it was going to work out for me. So I went and shot a picture of the sun. Glenn and I've decided we're not taking any telescopes this time. We're going to take some camping chairs, some filters, some binoculars, and just sit and watch it. And I think we're going to have a lot of stress-free fun watching the eclipse. That ends my nightmare presentation, folks. Are there any questions? I'm willing to take any questions now. Awesome.
Okay, so your camera, you had, it was ISO 400 with F what?
Okay, what I did was ISO 400 F, I think it was F11, a 250th of a second with a one of these black Mylar solar filters. Now, if you shoot a picture, you could go out and shoot a picture tomorrow just to see what exposure works for you so that when you're at the eclipse, you'll be ready to go. And so I would try a variety of things, and whatever works good, works good. The nice thing is the sun is very forgiving. You just get it on Adobe Photoshop and you adjust the brightness and contrast until it looks pretty. You know, I don't use Adobe Photoshop, I use ImageJ, but they all will do the trick. Any other questions?
Actually, I got a question for Tim. Did Clifford Otto ever email you? Tim?
No, Doug, I've not heard back from him.
Okay.
Yeah. Hey, Jeff, I have a question. You showed the photograph that you and your friend in Australia took, and that your students and you measured the size of Venus using the parallax method. That was on a transit. But remind me of what science Albert Einstein was doing. Was that a transit or an eclipse where he was testing his theory of relativity?
Okay, so somewhere around 1910 or 1906, he came up with the theory that the sun would have bent light. So I think the eclipse was later, like maybe 1917 or something. I don't remember the exact year. But what they did was they took a telescope and they photographed the place in the sky where the eclipse would be 6 months later at nighttime and got a fix of all the stars in that field. Then 6 months later, during the daytime, when the sun was in that particular spot, they took photographs of the eclipse again, and the exposures were deep enough so that they got stars. So then they would stack the two pictures together to see if the star positions were different during the eclipse. And as it turns out, the stars looked farther from the sun during the eclipse than not during the eclipse, because as the light went around, where's the camera? Am I in view?
I can move it when you're over there. Move it.
I'm so good looking. I want to make sure I'm here. Okay. So like, here's the sun and here's the earth, and the stars are back here. And so the stars would bend like that as a result of gravity. So the stars look like they're this way instead of this way. So from your point of view, they look farther away from the sun during the eclipse than they really are in space. And so it's not refraction, it's gravitational lensing, but it is a refraction. It's just not optical refraction, it's gravitational refraction. So, but it has to be the right way. Like the sun's here, it has to be lined up this way. It has to be lined up this way. They have to be radial towards the center of the sun. And it did, in fact, confirm the theory of relativity for gravity lensing. And then, of course, you see this all the time now. When we look out at space at quasars, we will see multiple images of quasars because there's a galaxy between us and the quasar that's bending that light. There's a quasar that we can hit with the 24-inch in Draco. Looks like a double quasar, but they have the exact same spectrum because they are the same quasar, that a galaxy between us and that quasar has bent the light. And so we see in two different locations. And so like any other telescope, not only does it change the direction, but it amplifies the light because it's a telescope. So this quasar in Draco is 9 billion light years away, but it's 17.5 magnitude, which it should have been 25th magnitude, but it's 17.5 because a astronomically sized telescope amplified the light a lot. And then you could see like bent galaxy images of galaxies that are beyond a cluster of galaxies. So we see this all the time now. But yeah, I think it was somewhere around 1917 when that eclipse happened. And again, I don't know the exact date.
Yeah, so that's kind of cool that you can do some science during an eclipse other than just a kind of a cool observing opportunity. What other science could us amateurs take on, Jeff? Can you think of anything that we could measure, observe during the eclipse, even the partial eclipse that we're going to have in Stockton?
So the stuff I've listed has been done, or the stuff I'm going to list has been done, but a person can do it to train themselves how it was done originally. So during a total solar eclipse, you can take spectrographs, slit spectrographs of the corona, and that you can't be doing that during the day. You can do a spectroscopy of the chromosphere because for a brief moment, the chromosphere is showing and the solar disk is not. So you can do a spectrograph of that, and you can come up with the fact that it's mostly hydrogen and some other stuff. During the last little moment of totality, the moon makes a very thin slit of the sun, and the diffraction going around the moon sets up diffraction patterns, and you can actually see these things. They're called shadow bands on the ground, and they're moving across the ground. And that's a freak out to see lines moved across the ground because of the diffraction that's happened 250,000 miles away. One thing I did during an annular eclipse was, as the moon crept in front of the sun, I tried to estimate how dark umbras and penumbras of sunspots are based on how dark the moon was. And so when the moon went across a sunspot, is the moon darker than the umbra, or are they about the same? And it is darker. So there is, when you look at the sunspots, you think they're just black, but they are not black. They're dark gray. Let's see, what other science could a person theoretically do here?
Temperature? Temperature.
Yeah, during the 2017 eclipse, I had my kids, they had a gray card and a meter stick and a light meter, 1 meter from the gray card, and it was pointing right at the sun. And I had them measure the light every 10 minutes throughout the duration of the eclipse. And so there's a dip and then it recovers, of course. Then we have temperatures. And so during the day, the temperature is climbing, but as the eclipse is occurring, the rate of change of the climb suspends a little bit and then picks back up again. So this is all recordable stuff.
One of the other things you can see during a total eclipse.
During a total eclipse, so first of all, you could see prominences and the chromosphere, and you could see the corona. None of those can be seen other than using a hydrogen alphascope.
Well, you can also see those. You probably see some other stars in the sky as it gets dark.
Yes, we saw Regulus right next to the sun at that last eclipse. And, you know, looking around to see what stars you can see, really a bad use of time during the eclipse, because the eclipse is really cool. It's like, gee, let's look over here, you know, we kind of not the thing to do, but you can do that. The thing that surprised me during the total eclipse was I thought that the prominences were going to be blood red, tomato red, just like they are in a hydrogen alphascope. And surprise, surprise, it's like a hot neon pink, almost a dusty rose, electric pink color. And that took me by surprise. It was just, I thought it was going to be blood red. It wasn't even close to blood red. So that tells me that the chemistry and prominences involve more than just hydrogen. And that actually shocked me a little bit. Bailey's beads, during a total eclipse, you can see Bailey's beads. And what that is just as the photosphere is being hidden from the sun, or just as it reappears, it pokes out in the valleys between the mountains and the limb of the moon. So you get all these bright arc welding looking dots around the side of the moon. Now, technically, you can observe this in an annular eclipse, but it's obviously a lot harder. The really cool thing is noticing the change in color when the eclipse gets done and it's coming back. Everything's just, I can't describe, it's just the wrong color. And so when we have an annular eclipse, and from my point of view, it'll be only 11% is bright out. It will look a little different, but again, you got to be almost 95% before it starts really showing itself. Oh, another one is shadows are really sharp. When you have like a crescent sun, the projection of the sun is really thin on one vector and wide on another. So if you look at your shadows, two sides of your shadows will be really sharp and the other sides will be blurry. You know how your shadow is a little blurry because it technically has a penumbra around it. That penumbra goes away when the sun is really thin. So your shadows get sharp. Anybody else remember anything cool in an eclipse they want to share?
Yes, everyone.
Well, I hope you guys weren't bored totally out of your brains. I hope you guys will report what you see for your eclipse, and we'll talk about it later.
Okay.
Yeah, thank you.
Excellent. Jeff, thank you so much. Let's put our hands together for Jeff Baldwin and that wonderful presentation. Excellent.
Thank you, Jeff. That was great.
Thank
Yeah.
you, Jeff.
Thank you.
Good job, Jeff. Okay, I've just got some announcements and some updates to share with you. So Eric, when you shift screens here, we'll go to that.
How's that?
Excellent. No photo credits due here. I just stole this image off the internet. So it's kind of a cool picture of a annular eclipse. But our upcoming meetings and star parties are listed here. I'll just go through them quickly. Obviously, we just talked at length about the Saturday annular eclipse, and I have another slide to show you the details of where you can come in Stockton for the SAS viewing. And then Saturday night, we also have a high altitude star party. Look at the Yahoo chat to find out where we're going, if we're going, depending on weather. But otherwise, it'd be the heliport or Peddler Hill. Just curious, anybody currently have plans to go to the high altitude star party? Bill or Eric, are you guys going to be in town or?
This is Eric. I'm going to be in Winnemucca as well. So
That's kind of high altitude, but I was looking for. So, okay. Well, so, and then coming up, the next Saturday, October 21st, is Astronomy in the Park out at Oak Grove. Doug, any special announcements regarding that event on?
Yeah, everybody show up. Let's go.
Everybody show up. We had a good turnout the last time in for September.
Between 80 and 100 people. So
Yeah.
the scopes out there.
So good. Okay, and then looking forward to next month, November 4th is Highway 4 Star Party. And Eric, I don't know if maybe you'll also want to try to get us up to Campo Seco to test that site one more time in early November.
yeah, sure.
Yeah. Okay. Our general meeting is November 9th, and that's also our elections night. So everybody please try to attend. We're going to have our executive committee elections for the club. And we also have a special presentation from Larry McHenry, still holding to this theme of eclipses. And he's going to talk to us about the 2024 total eclipse and some observing techniques and around that. The 11th of November is high altitude party, and then November 18th, another astronomy in the park out at Oak Grove. Looking forward into December, I just listed the one general meeting. For all you veterans of the club, you know that this is our annual show and tell meeting where we informally allow members to present on anything, almost anything they like, astronomy related. So be thinking now what you may have of interest to share with the other members of the club. It could be a place you went, a piece of gear that you bought, a book you read, an article, something of interest. So it doesn't have to be long. It doesn't have to be anything extensive, but just try to prepare something and contact one of the board members, contact me, and we'll get you on the list for the show and tell presentation in December. I know some of the members I've already talked to are already preparing something. I think Eric's got something. We're going to hear from him, and I'm going to try to prepare something. I'll keep it a surprise until then. But anyway, show and tell in December. So that's the announcements. If you go to the next slide, then Eric. This is the details of the Stockton viewing. That we've kind of joined forces with the Physics and Computer Science Club at San Joaquin Delta College. Kind of a nice relationship we've fostered there. Over Doug's worked with the professor there, Jacek, and he's invited us to join his students there Saturday morning. He lists the event from 9 a.m. to 10 a.m., although some of us are going to get there as early as 7:30 a.m. to set up, and we'll stick around till 10:45, 11 a.m. or so till the eclipse is fully over. So I'll be sending out an email to the whole club, all the members. You'll get an email probably tomorrow morning. I'll get this out that includes this map that Jacek has provided us. We're going to be meeting for the viewing in the community garden area. It's kind of on the north side of campus. Yeah, exactly where you're hovering there, Eric. You kind of enter past the fire station. You can enter off of Persian Avenue or Pacific as well. So anyway, again, I'll share this with you all in an email. So look for that map. And if you have questions how to get there, I'll list my phone number. We'll be out there, even if it's cloudy, because we may have a little peekaboo event where the clouds break open long enough for the eclipse to come through. So we don't want to miss it. We've got solar glasses to loan out to anybody. Although all of you in attendance tonight now have solar glasses. Thank you, Jeff, for that. Let's see, we're going to have the club's hydrogen alpha solar scope out there. Bill's bringing his telescope with a solar filter on it, that solar projection scope. And the students are setting up their solar scope. So Eric's been working with the students to get their solar scope calibrated and up and running. Eric, do you have any report? How are they doing? Were they successful in getting their scope working?
They were successful. Me and Bill met them on last Sunday, for a couple hours, helped walk them through setting up, and I think they will be able to do it.
Excellent. Thanks for your work to do that, Eric.
Question, Tim.
Yes.
Is someone else setting up observing in the center part of the campus? Because that's the flyer I've been sending out.
Yeah, Jerry. So just day before yesterday, Yasik sent out this revised new location. Previously, it was more located in the plaza area around the science and math building.
Right.
And he identified that there is some kind of, I want to say, Hispanic Culture Day event that he anticipated a possible conflict. And then this new location at the community gardens is actually a better horizon to the east and south for us to view from. So he's changed the location just recently.
Okay. Can I get a copy of this page that you have up right now?
Yes, as I mentioned, I'll send that out. I can even stay up a little bit late and send it out this evening. So I'll send you an email with this map embedded in it.
Appreciate that. Thank you.
Certainly. Certainly. Thanks for sharing that and advertising with others, Jerry, as well.
Mm-hmm.
So, hey, and then look at the photograph that I that landed in this slide, y'all. It's an eclipse under cloudy conditions. So I'm hoping that's not what we face, but you know, an eclipse technically could be visible through the clouds. So we'll see what happens on Saturday, right? So, okay, so that's our club's eclipse viewing for Saturday, and then one more announcement at the next slide, and that's a friendly reminder that your club dues are due starting October 1st. We collect them through December 31st. So several of you have already paid. Thank you. Several of us still need to send our dues in. And Jerry, correct me if I'm wrong, but probably the simplest way for everybody to send their dues is just to print out that back page of the Valley Skies newsletter and send that into Jerry with your information marked renewal. Anything you want to add to that, Jerry?
That works just fine, Tim.
Excellent. Excellent. Yeah. So we've got a pretty good, healthy membership right now. I think Jerry reported 58 members as of October. So hopefully our numbers are going to grow a little bit into the year, and looking forward to a really good active year with the club going into 2024. I snapped some photos of and landed them on this slide of past events, and hopefully we'll do even more kind of our annual Striking Sparks potluck out at Oak Grove. We're already planning. You guys help me remember the date that we've got planned for that for 2024. Go ahead and tell folks about that now.
I think it's May 18th.
May 18th, everyone.
I think it's May 18th.
Okay. We'll confirm all that, but definitely.
That's Mount St. Helens Day.
Is that right? That seems appropriate.
They've done that.
May 18th.
Okay. And thanks, Doug. So look forward to being out there and having a good event for the potluck and Striking Sparks and awards and such. So, okay, I think that's the last slide, isn't it, Eric, for the announcements?
Yes.
Then very good. Then in closing, well, anyone else have any announcements either on Zoom or in the room there?
ATM on November 4th.
Okay, November 4th, ATM. Thanks, Jeff. And you'll be sending a reminder out for that prior to that, I'm sure.
Now, am I leaving the solar projection scope with Bill or taking it home for you?
Bill's going to bring it to Delta on Saturday. So
Thanks.
yeah, thank you.
That's a great shot, Eric.
Yeah, that's a great shot.
Yeah.
The image I took just this past Sunday or Saturday, actually, practicing for the upcoming eclipse. But this is a recent image of the sun sharing with you right now. So hope you guys like it.
So since you're gonna be Winnemucca, could you take an extra shot and put my name on it?
Okay.
Oh, Eric, us on Zoom don't see what you're sharing.
Oh no. Oh, I didn't actually hit share. I'm sorry.
You don't get to see it.
Okay, Eric, why don't you
happy.
walk us through what you prepared and what you've done here and what we're seeing?
So this was taken through a Lunt 50 millimeter hydrogen alpha solar telescope, sitting on a small Skywatcher equatorial mount. The way this was taken was with a dedicated astronomy camera from company ZWO. That's one of their ASI line cameras. It's take with a monochrome, just with a little monochrome 1.25" cameras. Imaged it was taken as a video actually. So for roughly 1 minute, and then post-processed with a few different stacking programs, and the GIMP is an open source program similar to like Photoshop to colorize it. And one of the programs that I also use helps to draw out the details of the chromosphere, as well as the prominences. So overall, it's actually pretty easy. It doesn't take that long because you only take it like a 1 minute image. I mean, sorry, a 1 minute video, and then the programs just do everything. They just stack it for you, and then you spend maybe like a couple of minutes colorizing it, and you're done. It's actually one of the easiest things to do in astrophotography, in my opinion.
Do you have the other one where you have the darker detailing?
I can try to show that one. Let me bring that one up here. Let me find it first.
Because in this image, your sunspots are white. They're reverse
No, no, they're actually not white in this one.
Those aren't actually spots. Those are filaments and prominences.
I think you're referring to. Let me find it here.
Okay, are the dark areas, are those the sunspots on the surface?
Hydrogen alpha doesn't look at spots. The photosphere one looks at spots. These are other details. These are not spots.
Oh, okay, I understand.
Unless you have floaters in your eyes, then those are spots.
Or specks on my screen.
I don't know where the other image is.
So how do you get it so that it's kind of got that shiny side and dark side? It almost looks like a sphere being lit from one side.
From this side or left side?
Well, yeah, see how it's bright over there and dark on the other side? It's almost like it's a sphere that's being lit from one side, which is, I don't understand how that happened.
It's a binary system, Jeff.
Yeah,
It's
on that side.
to be honest, I don't know. It's not the only image I've done, and it's had that as well. So I think it's just probably an artifact of my camera's exposure settings that is creating that light side over there. But it's not.
That's just
it's not intentional.
Now, you said that when you piled their stacked images, and then when you didn't stack, they just kind of ended up the same?
Yeah, I'm sorry. I don't know where the other one is. Let me find it.
That's all right. That's all right.
Well, I guess I can go to the web when I send it out.
Okay, so Eric, while you're looking for that photograph, we'll come back to you in just a moment. I've got some thank yous to say as we kind of close the meeting here. Jeff, I want to thank you for being our speaker and wonderful presentation tonight, as well as providing the refreshments and the gifts of the solar glasses. So again, Jeff, thank you very much.
Thank you.
want to thank Eric for your work with the audio visual. Excellent job as usual. And you all know what effort and setup time that takes for Eric to do that. And so I want to thank you, Eric, for all that work you've done.
Yeah, no problem.
Rebecca is our newsletter editor, Rebecca Lewis Merrill. I want to thank her for her continued excellence in producing the Valley Skies newsletter. I think we sometimes take that for granted, but she's puts in several days or hours prior to sending that out and putting all the content together. So Rebecca, you're out there. Thank you very much. And then somebody you always hear from, he's puts in a ton of work constantly over the years for the club. And I want to recognize Jerry Hyatt for his work. Jerry, thank you very much. Your work as treasurer, newsletter, Striking Sparks, all the business workings of the Stockton Astronomical Society are as due to Jerry's efforts. So let's give Jerry a big hand and thank him for his work.
Oh, no, thank you. Thank you.
Thank you, Jerry.
And for being treasurer for 8 more years.
Yes. So, okay, Eric, back to you now. Go ahead and narrate.
Okay, so this image is a single frame taken from my 1-minute video. So, and then the image was inverted black and white before it was colorized. And so like on this one, this is why you see like the sunspots white.
So it's actually a negative?
It's actually more of a negative, yeah, and then colorized after the fact.
Yeah.
But it wasn't stacked, it was just a single image.
It has a weird, almost microscopic organism texture look to it.
Yeah. But instead of stacked, it still was sharpened and deconvoluted with software to bring out the details. But that was that one. But it got me thinking, why am I bother stacking them? Why? If you can get an image like that with a single shot.
I have a double Edelon lunt on my astrophysics, and if I can get some videos going, I might have you come over and mommy me through some pictures.
So then this one is the same image that before inverting it.
So did you invert the body but leave the perimeter alone?
Nope, whole thing was inverted.
So the whole thing was inverted. That's weird. So was it black and white before you colorized it?
I colorized it after inverting it.
But was it a monochromatic image that you colorized?
Yes, yes.
Okay, so what I'd like to do is, when I look at the sun, when I look at prominences, I see that hot pink, electric pink. That's got to be the color of the entire photosphere. I'd like to do the same thing, only in that dusty rose hot pink.
Yeah, you can.
That could be done, right?
Yeah.
Huh.
Well, with a black and white camera, you can colorize it however you want. It's really an artistic bit to that part of the hobby. Once you have the image, you can make the color any
This
color.
palette seems to be the most popular here.
Yeah, it is.
Yeah. I'll probably do that other color and say, oh, that looks like crap. Forget that.
Like the red and reddish tint to the other one was much lighter than this one.
That's just outstanding.
Yeah, it is beautiful. Yeah, good work, Eric.
Thanks.
Yeah. Okay, as we come to a close here in the meeting, anybody else have any comments or items you want to bring up? Okay, again, I want to thank you for attending tonight, both in person and via Zoom, and look forward to seeing you either at the next meeting or some of our star parties or events between now and then.
Yeah,
So,
I will not be there.
Guess that's it.
I guess that's it. Yeah.
okay,
Tim?
Hey, Tim, hope you're having a good vacation.
okay.